Alright, so in this video we're going to take a look at some of the laws that govern circuitry. So let's start off with some charge law. Are charges used up in the production of light in a light bulb? So what I'd like to do is pause the video so you can have a read through the 5 different options, select which one you think is correct, and then we'll take a look in a second. Alright, so now you've got your answer. The correct answer to this question is E. So the first thing is A, B, and C all violate the law of conservation of charge. So we can never use up or destroy charges, so that can't possibly be the answer. We also can't convert charges into something else. Charge is a fundamental characteristic of matter, so you can't do anything to transfer charge either. So A to D are all wrong because they violate our conservation laws, which leaves us with E having to be correct. But it also makes sense as well, because a current is essentially the movement of charges through a circuit, and as they move through different conductors, the charges will collide with parts of the conductor and transfer their kinetic energy to them, which you can think of as a kind of friction. And it definitely produces heat and produces light, so that makes sense in terms of a light bulb. Okay, so how does the power delivered to resistor A change when resistor B is added to the circuit? So have a look through the 5 options, decide which one you want to go for, then we'll take a look at the answer. Okay, so the correct answer is that it is reduced to 1/4. So you can see that in the second circuit, the resistors are all the same. So what we've done is we've doubled the resistance. And if we double the resistance, that means we have halved the current, because the voltage supplied to both circuits is the same. So essentially that means current and resistance are inversely proportional. So current is halved, P equals I squared R. Resistance of A is still the same. So if I is halved, that means power is going to be quartered. Okay. So which circuit or circuits have the greatest energy delivered to them per second? So have a look through the options, decide which answer you're going to pick, then we'll take a look. Okay, so the correct answer is circuit 3. So there's a few laws going on here. So the energy is being delivered to the same resistors each time, so that's not going to have an effect on it. What we need to think about is how having power sources in series and parallel affects the amount of energy we deliver. So the amount of energy delivered is the same in circuits 1 and 2. Having EMF sources in parallel does nothing to increase the amount of energy that we are providing, because the charges will only go through one of the power sources. Whereas in circuit 3, all of the charges have to go through both power sources, so they'll each add to each other and deliver more kinetic energy to the charges or more energy to the circuit. So that's why it's 3. Okay, so which circuit or circuits below represent a circuit with 2 light bulbs in parallel with a battery? So have a look through the options, select your answer. All right, so now you've got your answer. Let's go through each of them. So circuit 1, we see charges coming out of the battery can only go through one or the other resistor. So that tells us they're in parallel, so that works. It's the same for circuit 2. They can either go left or right out the battery, so they go through one resistor or the other, so they're in parallel. Circuit 3, all the charges must go through both resistors, therefore they're described as being in series. In circuit 4, all the charges will go through the first resistor, and then none of them will go through the second, because they'll all go through the route with no resistor, which we call a short circuit. So actually they wouldn't be described as either series or parallel. So the answer we want is circuits 1 and 2. Okay, so what we can do is we want to compare the resistance of branch 1 with that of branch 2. So the resistance of branch 1 is blank branch 2. So have a look through the options, select your answer, then we'll go through it. So Branch 1, we've got two resistors in series, so they'll have an effective resistance of 2R. Branch 2, we've got two resistors in parallel, so they'll have the effective resistance of R over 2 once you calculate it. So we can see branch 1 has 4 times the resistance of branch 2. Rank the potential difference between points 1 and 2, points 3 and 4, and points 4 and 5 in the circuit from highest to lowest. So have a look through the options, then we will take a look. Okay, so the first thing to recognize is that the EMF supplied by the power source is going to be shared between the two resistors. So that means that the potential difference between 3 and 4 plus the potential difference between 4 and 5 will be equal to the potential difference between 1 and 2. So that means potential difference between 1 and 2 has to be the biggest. So that's going to come first. So it has to be A, B, or E. Now, these two resistors are identical, so therefore 3 to 4 will be equal to 4 to 5. So that's going to tell us that it is option E. So compare the brightness of the bulb in circuit 1 with that of circuit 2. Which bulb is brighter? So have a look through the options and select your answer. Okay, so now you've got your answer. Let's take a look. So the correct answer is the circuit 1 bulb is brighter. And that's because two power sources in series will add together to give the charges more energy, which must be dissipated by the light bulb. Whereas two power sources in parallel do not add together. They will just essentially look the same as just one power source on its own. So compare the current at point 1 with the current at point 2. At which point is the current the largest? Select your answer. Let's take a look. Okay, so the answer that you should have had is that neither. They are exactly the same, and this is a DC power supply, so the current is only going to one direction around the circuit. It's going to go from 1 to 2. So which circuit will light the bulb? The other object in the circuit is a battery. So take a look and then select your answer, then we'll see what you should have had. Okay, so the correct answer is circuits 1 and 3. So the problem with circuits 2 and 4 is that the battery is only connected to the light bulb via one connection. And to have a complete circuit, every component must be attached to two connections. Therefore, it must be 1 and 3 are fine because they've got two connections with the battery. So compare the brightness of bulbs A, B, and C in these circuits. Which bulbs or bulbs are the brightest? So have a look through, select your answer, then we'll take a look. Okay, so the answer you should have is that A is the same as C. Now this isn't immediately obvious, but if we look at the first circuit in more detail, we can see all of the charges are going to go through A, and then none of them will go through B because there is a short circuit option with no resistance. So effectively A and C are in the same circuit and B will not light up at all because no current will go that way. Okay, so question 11. Why do the lights in your home come on almost instantaneously when you turn on the switch? So have a look through the option and then select the one you think is correct. Okay, so let's have a look at the correct answer. So the correct answer is A. So completing a circuit causes a rapid movement of charge around your circuit, and especially it rearranges the charges on the surface of the plates of your battery or your power source. That's the key to causing your circuit to supply energy and to create a current. It's on the plates of your battery or power source that you need a sudden increase in energy of your charges so that then they cause movement around your circuit. So if we have a look through the other options, charges don't store energy at all. Your power source is a store of energy and it just transfers it to kinetic energy in your charges. The charges do not travel very fast at all. Most drift velocities are a fraction of a millimeter. Circuits in a home are often wired in parallel, that's true, but current is definitely not already moving when you have a switch that's open. Charges in the wire are like marbles in a tube, and that when it's complete, the charges push each other through the wire. No, that's not true either. Thinking about that is not very helpful at all. You have electrons going randomly in all kinds of directions, and then your potential difference will give them a general trend in one direction. So consider the power delivered to each of the resistors shown in the circuit below. Which circuit or circuits have the least power delivered to them? So take a look through your options, pick one that you like. Okay, so the option you should have gone for is circuit 1 is the same as circuit 2. So circuit 3 will have the most power because you've got two sources working in series. In circuit 2, the two power sources are in parallel, so it makes no difference to just having one on its own. So they will be equal to each other and have the smallest power. The only reason we'd connect power sources like that is if one of them is like a backup source, so that if one breaks, the other one still works. Otherwise, there's no advantage. So which schematic diagram best represents the realistic circuit shown below? So take a look at the options and then we will show you which one's correct. Okay, so the one you should have is circuit 3. So we can see going around the outer loop, we've got two light bulbs in series, which you can see circuit 3 has. And then we've got one light bulb in a completely separate loop, which again, circuit 3 has. So how does the resistance between the endpoints change when the switch is closed? So select your answer, then we'll take a look. Okay, so the correct answer is it decreases by R/2. So when the switch is open, we've got two resistors in series, so that has a resistance of 2R. When the switch is closed, those two resistors become in parallel, so as they're identical, their combined resistance becomes R/2. That's in series with a resistance of R, so the total resistance is 3/2R, so it's decreased by R/2. So what happens to the potential difference between points 1 and 2 when the switch is closed? So have a look through your answers, then we'll take a look. Okay, so the correct answer is it stays the same. You should know that with components in parallel, adding more components in parallel has no effect on the other parallel components. In this instance, the potential difference between 1 and 2 is just going to be the same as the EMF source, and we could add as many parallel components as we like. So compare the brightness of bulb A with bulb B. Bulb A is blank bright as bulb B. So have a look through the options, then we'll get an answer. Okay, so the correct answer is equally bright. So we've seen earlier that adding EMF sources in parallel does nothing to your circuit, and nor does adding components in parallel either. So A and B are going to be exactly the same. So rank the currents at points 1, 2, 3, 4, 5, and 6 from highest to lowest. So have a look through the options, select your answer. Okay, so the correct answer is D. So we can see that 5 is the current coming out of the battery. So that's going to be the largest current. And we can see that that splits to go through 1 or 3. And since the resistors are equal, it will split equally. So the current going through 1 is the same as the current going through 3, but each of those is half of the current going through 5. So that essentially leads us to the next one, because the current in 2 is the same as 1, the current in 4 is the same as 3, and the current in 6 is the same as 5. So that gives us option D. So which circuits will light the bulb? So have a look through the options, then we'll see what the answer is. Okay, so The only one that will actually work is circuit 4. So for circuit 1 and 3 have very obvious breaks, so there's only one connection to the battery, so those obviously won't work. And you can see with circuit 2, you provided a wire allowing the current to bypass the bulb. So the current will, because that's a lower resistance route, so that bulb won't turn on either. So what happens to the brightness of bulbs A and B when a wire is connected between points 1 and 2? Have a look through your options. Let's see what you think. Okay, so the correct answer is nothing happens whatsoever, because the current pathway to go round through 1 and the pathway from 2 to 1 are both zero resistance, so it really won't change anything. The same number of charges will go through A and B. That's not going to have any effect on the circuit. Okay, so is the electric field zero or non-zero inside the bulb filament? So have a look through your options, then select your answer. Okay, so the correct answer here is non-zero. So there are going to be, as it says, charges on the surface of the filament which produce an electric field. So there are charges everywhere in our circuit, each of them creating its own electric field. So anywhere there is a charge, there's going to be an electric field. So that answer makes the most sense. But option D doesn't make sense because moving charges produce magnetic fields, they don't produce electric fields. Okay, so compare the energy delivered per second to each bulb shown below. Which bulb or bulbs have the least energy delivered to them per second? So have a look through, select your answer, then we'll take a look. Okay, so the correct answer is option D. So you should have realized that the current through B and C is half that of A. And since power depends on current, that means the power delivered to B or C will be equal but lower than A. Okay, so which realistic circuit or circuits represent the schematic diagram shown below? So select your answer, then we'll take a look. Okay, so the correct answer is just circuit 3. So circuit 1 has two parallel loops of light bulbs in there, so that doesn't work. Circuit 2 also has a parallel section as well, so that's not going to work. Circuit 3, each light bulb has two connections, each leading into the next one, so they're clearly in series. But if we take a look at circuit 4, we can see that the second terminal of the bulbs at the bottom is not connected into the circuit. Those light bulbs have been bypassed. There is effectively only two light bulbs in that circuit. Okay. So immediately after the switch is open, what happens to the resistance of the bulb? So have a look through your options, then we'll have a look. Okay, so the correct answer is the resistance stays the same. Whether there is current flowing or not, in the immediate moment you close the switch and turn on the current, the resistance is going to stay the same because there's been no opportunity for temperature to change immediately after the switch is opened or closed, so the resistance will stay the same. So if you double the current through a battery, is the potential difference across a battery doubled? So have a look through your options, then we'll take a look. Okay, so the correct answer here is D, no. So you should know potential difference, or as we commonly call it, EMF, is determined by the chemicals that are inside your battery. And that's something you will learn a bit more about if you do cells in A-level chemistry. So there's nothing you can do to change the EMF of an individual battery, it's just a property. So compare the brightness of bulb A with bulb B. Bulb A is blank bright as bulb B. So select your answer, let's take a look. Okay, so this is very similar to a question we've seen before. we've got twice as much resistance in the second circuit, therefore half as much current because we've got the same EMF. Power is equal to current squared times R. So if the current is halved, power is quartered, therefore bulb A is 4 times brighter than bulb B. Okay, so if you increase the resistance C, what happens to the brightness of bulbs A and B? So take a look through, select your answer, then we'll see what it is. All right, so the correct answer is the brightness of A and B would decrease. And the reason for that is that it will cause the current in the circuit to decrease. And once the current is decreased, the power dissipated by A and B will be smaller, so they will be not as bright, or they'll be dimmer. 27. Will all the bulbs be the same brightness? So take a look through the options, then we'll see what the answer is. Okay, so the answer is no, because only one of these circuits will actually work. So circuit 1, that bulb is not connected in the circuit, it's only connected in one terminal. Circuit 2 will work, it's connected in 2 terminals, so that's fine. Circuit 3, one of the connections is to the glass, not to the second terminal, so that's not going to work. Circuit 4, that bulb is not in the circuit because both of the wires go into the same terminal. And it's the same with circuit 5, that bulb is only connected in one location, that's not in the circuit. Okay, getting towards the end now, 28. What is the potential difference between points A and B? So, have a look through the options, select your answer, then we'll take a look. Okay, so the correct answer is 12 volts. So, because there is no current flowing in the circuit, the potential at A must be 12 volts because there's been no opportunity to lose it. Likewise, at B, it must be 0 because it's connected to the 0 terminal of the battery, so the difference between them will be 12 volts. And final question, what happens to the brightness of bulbs A and B when the switch is closed? So take a look at your options, then we'll see what we get. Okay, so the correct answer is A gets brighter and B dims. So adding a component in parallel with B will decrease the overall circuit resistance. And what that means is the overall circuit current will increase. So there's a higher current going through A, therefore it will get brighter. However, to start with, all of the current was going through B, but now it's splitting between B and C, so the current through B will be smaller, which is why it dims. Okay, so that finished this video looking at resistance style circuits and some of the circuitry laws. I hope you found that useful to help you evaluate how well you understand the laws that govern circuits and maybe seen some more obscure ways of testing them. So if you have any questions following this video, please do feel free to comment and ask me those questions. I'll get back to you as quick as I can. But thank you for taking the time to watch.